6.8 is going to be our last lesson for our Unit 1, and what we're going to be looking at are inverse functions. We're going to be first able to decide if given two equations, they are in fact inverses of each other, and then we're also going to be given one equation, and you're going to have to be able to figure out what is the inverse of that equation. Alright, so here are some definitions. So f of x and g of x are considered inverses of each other if when you take the composition of them, see this notation, we can see what's going on here. We're taking the composition of f of x and g of x. If when we take the composition of them, they just get us x. Alright, so let's just consider a very easy scenario. We know inverse operations, right? They're just opposite operations, ones that undo each other. So if you were to take this by its very definition, if I took f of g of x, that would be saying, remember this from the last section, we're taking f of whatever this output is that we got for g of x, and we're putting that output in as our input into the f function. So it's 4 times x over 4. Now keep in mind those will cancel each other out. Yes, we did get our x like we wanted to. Alright, same thing goes the other direction. We need to be able to do both. So now we're going to be taking our f of x, whatever that was, oops, here it is, and we're going to be plugging that in as an input to our g of x function. So we get our x. Okay, so by definition, these are inverses of each other, and we kind of already knew that because division and multiplication inverses. Oops. Alright, so g of x is referred to as the inverse function of f of x. We label it with this notation. Instead of just saying g of x, we can specifically label it and stamp it. You know, stamping. That's what we've been doing with these equations. We're stamping it with an f to the negative 1 of x, so that way we can see automatically. I'm going to take that out and I'm going to write it as f of x with the negative 1 as the notation, and now I can clearly see, oh yeah, these are inverses of each other because this has been stamped as such. Alright, so here is just a quick kind of idea. So let's look at our function. Remember, functions are just machines, right? So here's our function, and we're going to take some sort of input, and that function is going to square it. So here's our machine doing its work, and what outpops, or what outpops? What is our output? Well, it's 64, because 8 squared would become 64, right? Input, output. Inverse functions, they're the anti-function, right? So they're going to be taking all this work that our function x squared did, he's going to undo it, alright? So then what we're going to be is right back where we started with that input of 8. So inverse relations, or inverse functions, they undo each other. So here's just one kind of quick idea, then, is knowing that basically these x and y values, the roles completely swap. So let's look at the y equals x squared, or f of x equals x squared. Here's our happy little cute function, right? And what he does is he's going to take all these values and he's going to, oopsies, and he's going to output the squared of whatever that input is. So 0 squared, 0. But then that nasty anti-function comes along, and much to x squared's disdain, it's going to take that output and turn it back into the input. So that's kind of a bad example. But let's look at, no, that's a bad example too. Let's look at 2 squared, which would have gotten 4, right? He did all this work, he got 4. Nasty anti-function, or inverse function, comes along, takes that output, right, and undoes it. So he square roots that 4 to get 2. Same thing with this 3. He would have outputted 9, but then anti-function comes along, takes the 9, outputs 3. So what you can see is that these are going to completely be swapped, right? So what happens is the x and the y, their roles swap, and you can see that as evident in the charts. Okay, so here's just a quick thing. You need to, as part of one of the objectives, give me like 10 minutes. Sorry. Okay. Alright, and then I'll help where you have holes. As part of our objectives, one of the things that we must be able to do is to decide if two functions are inverses of each other. So what we're going to do is we're going to take the composition of the two functions. By definition, if they are inverses, then they should equal x. So first objective in this video was to decide if two given equations are indeed inverses of each other, take the composition of them and decide if you got x. If they don't equal x in the end, then they're not inverses. So let's take an example of this. Number 16, I'll read you the directions off the book. It says, show that f and g are inverse functions, algebraically and graphically. So let's go ahead with number 16. We have f of x equals 3 minus 4x, and we have g of x equals 3 minus x over 4. So algebraically, we're just going to go ahead and do the composition. So f of g of x. Right, and here I go. I'm going to take that g of x and I'm going to input it into my f function. So here's my inner function. That's what's going to be the input into the outer function. So we have 3 minus 4 times 3 minus x over 4. Okay, these are going to cancel each other out because we just multiply straight across the top, straight across the bottom, and those are reduced. We have now 3 minus, in parentheses, 3 minus x. So just be very careful with the distribution of this. We're going to get 3 minus 3 plus x. These cancel each other out. We sure did get our x. If we took g of f of x, that means we're inputting this inner function of f of x into the other. So we have g of 3 minus 4x. This is going in as an input into this g-defined function. So 3 minus, in parentheses, 3 minus 4x all over 4. And you will see here again, these have to distribute. Okay, and then this is a plus. So 3 minus 3, they cancel out. 4x divided by 4, x. Alright, if you want to, you can go ahead and do an XY table of these and see what happens, but when you do your XY table, XY of your f of x, and then go ahead and do one of the g of x, what should happen is you'll get opposite parents. So if you did 0, 1, 2, 3, plug those in, for f of x we would get 3, negative 1, negative 5, negative 9, because we have a slope of negative 4, so that's the rate of change. We started at 3. So now if you plug these in, and you plug it in over here, so what's 3? We're going to get 3 minus 3 over 4 is 0. Negative 1, so 3 minus negative 1, that's going to be 3 plus 1, so that's going to get us 1. 1. And what you will see is these do end up being the same. So graphically as well, they check out to be inverses. Alright, so now that we have completed objective number 1, which is to confirm whether or not two functions are inverses of each other, now we're going to look at the requirements of finding an inverse function. The first thing is, you can only have an inverse function if the original function was 1 to 1. So this means that not only does it pass the vertical line test, but it also passes the horizontal line test. So now you have to check both. Because what happens is we have a flip of our graph. So if we had something like this, and you'll see this the more you graph them, you're going to have something like this. It kind of flips it on its side because it's a reflection over this line. So you'll see that when you do the plotting of these types of inverse pairings, but if you have a function that's not 1 to 1, so it doesn't pass the horizontal line test, keep in mind the x and y roles swap. So remember, these guys can cheat, but what will happen is when you flip it over, the cheating is not okay now because that inverse is no longer a function. Alright, if a function is not 1 to 1, we do call it an inverse relation, just not a function. Okay. So if we did consider this, well, no. Okay. So with that in mind, now that you know what you need to have in order to find an inverse function, these are the steps to find the inverse function. So please do write these down. I'll do number 45 with you. We'll follow these steps. Okay, they do give us a domain, and they do give it an interval notation. Alright, here is our domain. Alright, so here's our domain. So the idea is what we need to do is we're going to change f of x to y. So that just gets us back to our x and y. And we're going to reverse the roles because, again, what we do know is with these inverse functions, these roles reverse. So I'm going to go ahead and say that x is now equal to 4 minus y squared. And what we're going to do is we're going to solve for y, because when we solve for y, we're going to be unraveling everything on this function. So remember, we want to just get x by itself when we plug it into a composition. So the operations that are going to undo everything will be documented as I solve for y here. So let's go ahead and do that. So I need to get rid of this square root, so I'm going to square both sides. X squared equals, and then 4 minus y squared. I'm going to change this to plus and negative. Alright, so now I can't undo, we're using SADMAP, remember, the reverse order of PEMDAS as you solve for a variable. So subtraction or addition has to go. This plus 4 needs to go, so I'm going to subtract 4. Gone. I'm going to have to write over here, x squared minus 4 equals negative y squared. I'm going to divide by negative 1. So now I'm going to get negative x squared plus 4 equals y squared. And then finally I'm going to square root. So plus minus square root negative x squared plus 4 equals y. Okay, but now keep in mind this was the domain. Okay, so this will affect things. So what we do want is, now you can go ahead and stamp this. F to the negative 1 of x then is going to be equal to the plus minus, but I'm going to hold back for a second. I'm going to write this as 4 minus x squared. So what I'm going to say is, we know that right now this range is plus and minus values. So remember, the domain are all possible x values, and I want to now transfer that to that the range of our inverse, because again those roles switch, is going to be from 0 to 2. So we only want the positive here. So we'll kind of discuss that in class tomorrow. But this right here is our inverse function. And one last one, let's do an example. Determine whether the function has an inverse. If it does, now this just simply is 3/5 x plus 4/5. That is a line, so it definitely passes the 1-to-1 test. It is therefore going to have an inverse function. So now let's go ahead and do that. Y equals 3x plus 4. That was the first step. Then we're going to swap the roles because I'm trying to find the inverse function, and I'm going to solve for y, so I'm now going to document everything that would undo stuff onto this x, because that's going to be the inverse function. So we're going to multiply by 5, that's gone. We have 5x equals 3y plus 4, so I'm going to subtract 4, 5x minus 4 equals 3y, divide by 3. Alright, so y equals 5x minus 4 over 3. If you were to take this, and you were, f to the negative 1 of x, I'm going to stamp it, because now I can clearly see, oh, these guys have a special relationship. This thing is going to undo everything about that. There's your homework. Good luck. I was so close to being done with this. Yeah.